Alright, let's solve another problem. Let's get into it. Problems. Pick one for me, please. Longest nice subarray. You're given an array nums consisting of positive integers. We call a subarray of nums nice if bitwise and of every pair of elements that are in different positions in the subarray is equal to 0. Return the length of the longest nice subarray. What does bitwise and do? Is that like parity? 3 and 48 is 0. 8 and 48 is 0. What does bitwise and do? Oh, so it gets like the bits of it. Interesting. How do I do this? So we get the, is it the least significant bit? Five input 1 bitwise and will get you a 1 bitwise or bitwise XOR. Okay. Okay, so they don't match up at all. Cool. What's my thought process? So if we have 101 and 010, I get you 0, which is what we want. If we have 001, but if you have 001, then you get 1. Okay. So I think you have to compare it. Okay, whenever you add a new element, it has to be compared to the rest of the elements. So you're looking at O of n squared time, I think, because you go through each element and you go through like all the elements of each subarray. So that'd be O of n squared, which is not fun, I'd say. So what is the more efficient solution here? What is the most efficient way? Because we have to compare with every element already, I guess, I mean, you can still do left and right pointers. You just have to have a current like bit number that keeps track of all the bitwise ands leading up to it, right? And whenever, okay, yeah, I think you could, yeah, you can definitely do sliding window method. Yeah, that's what I'm thinking. Okay, yeah, so I'm confirmed right for sliding window. Let's implement that. Current, I don't know, curval, cur is equal to nums 0. What's the length of this thing? At least 1, cool. And then we can also have our answer as 0. And then let's return answer. Return answer while r is less than, length of nums. We should also handle the edge case for that, I think. Yeah. Edge case, if length of nums is equal to 1, return 1. Cool. So now that we have LR is 0 and 1, and the current number is nums 0, our answer is equal to 0. Well, R is less than nums. If nums, if cur bitwise and what is bitwise and operator in Python? What is it? Oh, it's the and symbol? Okay. Yeah. If cur and then nums r is equal to 0, I mean, okay, if cur is equal to 0, and we update our answer. Answer is equal to max of answer r minus L. Okay, and else we have to update our values again. So L will now equal to R. L is equal to R. Cur is equal to nums L, and R plus equals 1 no matter what. And I think this should get our answer. I think this should work. No, it doesn't work. For this one, it works. Cool. What's the problem here? So it said that we should have 1. I mean, I feel like the answer is always 1. Max of 1 and ends. Ooh, it doesn't work. Okay. It clearly doesn't work for some of these test cases. Okay, that's annoying because now I don't know what to do. I guess, do you really have to bitwise and every single thing together? Because like if you do, yeah, you could just bitwise and everything together. I don't know what's wrong. It would have to be like my indexing somewhere that's wrong. else L is equal to R. I honestly don't know what's wrong here. I think. What is wrong here? Let's look at the hints first before I search up the answer. What is the maximum possible length of a nice subarray? Okay, the length of nums. The length of the longest nice subarray cannot exceed 30. Why is that? Because what? It can't exceed 30? Why not? I'm not sure, actually. It can't exceed 30. Was that because of, like, the bits? 2 to the 30 is what? Huh. That is interesting. Can't exceed 30. What if we work backwards from like the longest length, and then we sliding window on each thing? But how would you undo like all the ands? Do you do like an XOR? I'm not sure. I'm gonna have to ask ChatGPT for this one. I'm just kind of sucky, but hey, what's wrong with my code? Can you just give me a hint? Your code is almost correct, but there's an issue with the way you handle the bitwise AND operation and the movement of the left pointer. Specifically, when the bitwise AND result is not 0, you should reset cur by iterating from the current L to R. Why? Also, you should include the leftmost element in the subarray whenever cur is equal to 0. Here's a hint. Instead of resetting L to R, try shifting L to the right until cur becomes 0 again, and update cur accordingly. This way you ensure that the subarray is still valid. What? Okay, okay. So I want to include, okay. Huh. Let's see. While R is less than the length of nums, we want to double while loop. Interesting. I'm gonna try to understand this. So we initialize L, R, current, ands. While R is less than length of nums, okay? While the current value and nums R is not equal to 0. So while there is no Oh, this is the undoing thing. Oh, okay. Exclusive OR. So we undo from the left side, and we increment on the right, and we increment from the left, and then we. What does that do? We OR the right. Why? Why do we OR the right after that? Why did you do her or nums are? Oh, so you have to check the conflict. And then we do bitwise OR sync to the new element. No, wait. This is so wrong. Oh. Wait, what? Why do you do bitwise OR? I thought we were going for bitwise AND. I don't think... Why is this right? Because if you do bitwise OR, and then you check for the bitwise AND... Okay. I'm low-key confused, but... bitwise XOR plus equals 1. This is actually really difficult. So it undoes the left operation, and we increment the left to find the next good subarray. So we undo it, cool. And this thing is the bitwise OR function. Not really sure what this does. TBH, but it incorporates the R value into the curve that we check. Answer is equal to max. Answer R plus L plus 1. R plus equals 1. I don't think this will. Oh, it does work. Interesting. Cool. Alright. That was a rough problem, but I'll definitely take note of this.